Welcome once again to 242 Math. I am your host Raphael Thompson, and today we'll be looking at the topic of LCM in math, lowest common multiple, for grades 7 and 8 or high schoolers. Let's begin with a word problem. The soccer team meets for practice every 5 days, and the football team meets every 3 days. They both use the same field. If they are sharing the field today, in how many days will they have to share the field again? Now, to solve this, the number of days will be the LCM of 5 and 3. So let's see if we can figure out how to find the LCM of those two numbers. First of all, we need to know what multiples are. What is a multiple? A multiple is k times a number where k is a natural number, or a multiple is a number that can be divided by another without a remainder, or the remainder is equal to 0. So both of those definitions would suffice for what is a multiple. So once we know that, then we can look at solving the word problem we had earlier. First of all, let's look at some multiples. List the first 10 multiples of 5. Remember, there are many more multiples of 5. We just want the first 10. So see if you can come up with those numbers. Remember, in timetables, in an earlier video, I showed you how you can count in 5s for your 5 timetables. So that's all we're dealing with, the 5 timetables of multiples of 5. What's the first multiple? And then we need 9 more. Let's see if you can get that answer quickly. Yes, here it is. The first multiple of 5 is 5. It's 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Those are your first 10 multiples of 5. And the first multiple of a number would be that very number. So that's easy to remember and not get confused with factors. Let's list the first 10 multiples of 3. Remember what I said earlier, once you can count in 3s, then you would know the multiples of 3. We just want the first 10. See if you can do it quickly before the answer shows up. Remember, the first multiple of 3 is what? Yes, the first multiple of 3 is 3. So let's see if your answers are the same as this. Here it is. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Yeah, those are the first 10 multiples of 3. And all you have to do is skip counting 3s. And remember, the first multiple for 3 is the number 3. So don't get confused with multiples and factors. Now, let's finish work it. The multiples of 5, you already know what they are. We listed them: 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. The first multiples of 3, we already listed them: the first 10, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. You see the numbers in green? Yeah, they are the common multiples. So the common multiples of 15 and 30, I have those numbers in green in the listing. You need that in order to work out the lowest common multiple, which we have worked out here. So the common multiples of 15 and 30. Look at 15 and 30. Which number is the lowest, the lower number? And the lower number is 15. So the lowest common multiple, or the LCM, of 5 and 3 is equal to 15. So once you know the common multiples, pick out the lower one or the lowest one, and that would be your answer. So go back to the word problem. The soccer team meets for practice every 5 days. Football team meets every 3 days. They both use the same field. If they're sharing the field today, in how many days will they have to share the field again? Answer: they will share the field again in 15 days. We just worked out the LCM of 5 and 3. The LCM of 5 and 3 is 15. So that's your answer for that word problem. So once we know that, we can go on from there and work out some more problems for LCM. Remember, the LCM would be the lowest number both numbers can go into without a remainder. A, what is the LCM of 2 and 3? 2 and 3 are prime numbers, so you just multiply. LCM is 2 times 3 gets 6. B, what is the LCM of 5 and 7? Are they prime numbers? Yes, so just multiply them. LCM is equal to 5 times 7, 35. C, what's the LCM of 2 and 6? LCM of 2 and 6 is 2 times 6 equal to 12. Wrong answer. The LCM of 2 and 6 is not 12. So why 6 is not a prime number? So now let's determine the LCM of two numbers by listing multiples, and let's deal with that very same one we got wrong, the LCM of 2 and 6, which is not 12. The multiples of 2, let's list some of them: 2, 4, 6, 8, 10, 12, 14, 16, 18, and so on. Multiples of 6, 6, 12, 18, 24, 30, and so on. Remember, the multiples are ongoing. We just listed a couple of the multiples to work out the problem for the LCM of 2 and 6. So once you identify the common multiples in blue, the common multiples are 6, 12, 18, and so on. So once you know what the common multiples are, look at them. Which number is the lowest? The lowest number is 6. So the LCM of 2 and 6 is 6, not 12. 12 isn't the lowest number, not 18. 18 isn't the lowest number. The lowest number would be 6. Now let's determine the LCM of two numbers by using prime factorization. This is where students get mixed up between multiples and factors. Find the LCM of 2 and 6. Let's factorize 2. So if you factorize 2, put the division bracket there. Divide 2 into 2, you get 1. Stop. So 2 has one prime factor. That prime factor is 2. So 2 is equal to 2. The prime factor of 2 is 2. Now once you've done that, let's factorize 6. So put the division brackets and divide 2 into 6 3 times. Then you say 3 into 3, 1. Stop with the division. Once you get 1, the prime factors of 6 are 2 and 3. So 6 is equal to 2 times 3. Those are your prime factors. Okay, but don't get mixed up with LCM and HCF. You're using the factors, the prime factors, to find the LCM. Find the LCM of 2 and 6. We already factorized 2. 6 is 2 times 3. Prime factors are 2 and 3. Use each factor once. So the lowest common multiple is 2 times 3 is equal to 6. Use all the prime factors and use the greatest number for each factor. So the prime, 2 is a prime factor, 2 and 2, and there's a 2 with the 6, and then there's a 3 with the 6. So you have to use all of the factors, but only use it once. Now let's determine the LCM of two numbers by listing multiples. Let's do a second one, the LCM of 4 and 6. Let's list the multiples, some of the multiples. 4, 8, 12, 16, 20, 24, you're counting in 4s. And for 6, 6, 12, 18, 24, 30, 36, you're counting in 6s. So once you've done that, then you want to identify the common multiples. And I have those highlighted already in blue. So the common multiples would be 12 and 24. Which is the lower number? The lower number would be 12. So 12 would be the lowest common multiple, or the LCM of 4 and 6, not 24. 24 is not the lowest multiple. The lowest one would be 12. Okay, so you've done that. Let's do by prime factorization now. Same numbers, 4 and 6. Let's factorize 4. Put your division brackets. Divide 2 into 4. Goes 2 times. Then divide 2 into 2. 1. Stop. So the prime factor of 4 is 2. Now when you write it out, 4 is equal to 2 times 2, or 2 squared. So that's how you write out the prime factorization for 4. Now we have to do the prime factorization of 6. Let's factorize 6, division brackets. 2 into 6. Once it's an even number, you begin with 2. 2 into 6, then you go on to 3, and then 5. 2 into 6 goes 3, then 3 into 3, 1, stop. The prime factors of 6 are 2 and 3, so 6 is equal to 2 times 3. Once you've done the division, that's what you get. Now we have to look at how we will find the LCM. So we already have 4 is equal to 2 times 2, or 2 squared. 6 is equal to 2 times 3. So the factors, the prime factors are 2 and 3 for both numbers. So look at the 2. What do you use for the 2? The greatest number of factors. So 2 times 2 is what you use for the 2. And there's only one 3, so you use the 3. So the LCM would be 2 times 2 times 3, which is 12. Remember, use all the prime factors and use the greatest number for each factor. And that's how you determine the LCM. Okay, let's go on to another one. Find the LCM of 8 and 12. And we do this by listing the multiples first. Multiples of 8, 8, 16, 24, 32, 40, 48. Multiples of 12, 12, 24, 36, 48, 60. Common multiples would be 24 and 48, which we have highlighted in blue. Once you have the common multiples, which one is the lower number or the lowest number? In this case, it would be 24. Now let's do the same thing by prime factorization. So let's factorize 8. So 8 is an even number. Begin dividing by 2. 2 into 8, 4. divide by 2, 2 in the 4, 2. So the factors, the prime factor of 8 is 2, and if you write out the prime factorization to be 8 is equal to 2 times 2 times 2 is equal to 2 to the power 3 or 2/3. 2 to the power 3 for 8. 2 cubed would be the power you're looking at. Determine the factorization of 12. Let's do the division brackets and say 2 into 12, 2 into 12, 6, then divide again by 2, 2 into 6, 3, then divide by 3, and you end up with 1. So the prime factors of 12 are 2 and 3. And if you write it out for the prime factorization for 12, you get 12 is equal to 2 times 2 times 3 is equal to 2 squared times 3. 2 times 2 times 3. Now we have to look at the LCM. And remember, we have to look at all of the factors. So we already know 8 is 2 times 2 times 2, 12 is 2 times 2 times 3. So the factors we are looking at, the prime factors are 2 and 3. For the 2, which one do you use? 2 times 2 or 2 times 2 times 2? You use 2 times 2 times 2, the larger one. And then you have to still use the 3, so you get 24. So the lowest common multiple of 8 and 12 is 24. And you have to use all the prime factors and use the greatest number for each factor in order to determine what it is. So in this case, it's 24. Now, let's have some practice. List the first 5 multiples of these numbers, and let's start with 3. Counting in threes, you need to list the first 5 multiples. What's the first multiple of 3? It's 3. And then put 4 more. So let's see if you can get that done. The first 5 multiples of 3. Number 2, same thing. The first 5 multiples of 7. What's the first multiple of 7? Yes, 7. So list 4 more. You want the first 5 multiples of 7. 7 timetables. Only the first 5. Do it quickly. Yes, and number 3, first 5 multiples of 9. Your 9 timetables. And in the previous video, I showed you how to do your 9 timetables the easy way. I just want the first 5 multiples of 9. Remember, the first multiple of 9 is 9. Yes, so do 4 more. That's number 3. Number 4, the first 5 multiples of 10. Just skip counting tens. I showed you how to do this earlier. What's the first multiple of 10? It has to be the number itself, which is 10. So once you know that, put 10 and put 4 more multiples. 10 timetables. Got it? Good. Here are your answers. Check them. 1, 3. So it's 3, 6, 9, 12, 15. All of them to get that correct. 2, 7, 7, 14, 21, 28, 35, 9, 9, 18, 27, 36, 45, and 10, 10, 20, 30, 40, 50. Those are your 5 multiples for each of those numbers that we had. So you must be able to do that. If you're going to list the multiples, you must know the tables. Now, let's determine the LCM of 2 numbers by listing the multiples. So let's find the LCM of 6 and 8. First, you must list the multiples of 6, and then list the multiples of 8, and then write the common multiples. And from those common multiples, pick out the lowest common multiple for the answer for the LCM of 6 and 8. So do it quickly. Do some multiples of 6. And here we go. Multiples of 6. 6, 12, 18, 24, 30, 36, 42, 48, and so on. Multiples of 8, 8, 16, 24, 32, 40, 48, 56, 64, and so on. Common multiples, 24 and 48. Lowest common multiple would be 24. So the lowest number that 6 and 8 can go into would be 24 without a remainder. So we've done for 6 and 8. Now number 2. Find the LCM of 12 and 18, and we're listing the multiples. But now you see how hard it gets. Now you have to list multiples of 12 and then list some multiples of 18. So it gets hard when you have big numbers like these to find the LCM. That's why it's better to use the method of prime factorization. than listing the multiples. But do it quickly. Let's see if you can get this correct. Once you have the multiples, then do common multiples and then the lowest common multiple. There we go. 12, 12, 24, 36, 48, 60, 72, 18, 18, 36, 54, 72, 90, 108. Common multiples, in this case 36, 72, and so on. The lowest common multiple is 36. So the lowest number that 12 and 18 can go into is 36. We did that by listing the multiples, which is a bit hard. So the best way to tackle big numbers would be to use the prime factorization. So let's deal with prime factors and see if we can do that. Find the prime factors of these numbers. And we're dealing with 12. Remember, once it's an even number, you can begin dividing by 2. So set up your division brackets and begin your division. And you start with 2 into 12 and see what you get. You have to do your division brackets to do the prime factorization, to find the factors of 12, the prime factors of 12. Do the same thing for this. Give me the prime factors of 15. Now this is not an even number, so you can't use 2, so you begin by using 3. And if you can't use 3, then you use 5 and then 7. So begin dividing by 3 and see if you can do the prime factorization of 15. Use your division brackets and see what you get for 15. Number 3, 18. Is this an even number? Yes. So when you do your division brackets, begin dividing by 2. So you say 2 into 18, get an answer, and then continue from there to do the prime factorization to find the prime factors. Remember, we're only interested in the prime factors in order to figure out the LCM. Okay, and number 4, 24, do the same thing. I want the prime factors of 24. So begin with your division brackets, and since it's an even number, you would say 2 into 24. So begin dividing by 2 and continue dividing using the division brackets until you get 1, and then write your answer to show the prime factorization of 24. We're only interested in prime factors. Okay, first one, let's see if you got it correct. The division brackets, so you say 2 into 12, 6, 2 into 6, 3, 2 into 3, 1. Stop. The prime factors for 12 would be 2 and 3, so you write it. 12 is equal to 2 times 2 times 3. Perfect. That's all we need. Or you can say 2 squared times 3. Same thing. So if you got that correct, excellent job. We move on to number 2, 15. Division brackets, divide 3 into 15 5 times, then divide 5 into 5, 1. Stop. Prime factors would be 3 and 5 for 15, so you write it. 15 is equal to 3 times 5. That's it. That's your prime factorization of 15. And since it was not an even number, 15 is an odd number, you begin dividing by 3. Number 3, 18. You say 2 into 18, 9. Then 3 into 9, because 9 is an odd number. 3 into 9, 3. Then 3 into 3, 1. Stop. So your prime factors for 18 are 2 and 3. And if you write it out, 18 is equal to 2 times 3 times 3, or 2 times 3 squared. Those would be your prime factors, the prime factorization of 18. 18, 2 times 3 times 3. That's correct. And number 4, 24, begin dividing by 2 in your division brackets. 2 into 24, 12. 2 into 12, 6. 2 into 6, 3. Then 3 into 3, 1. Stop. So your prime factors for 12 would be 2 and 3. And if you write it out, 24 is equal to 2 times 2 times 3, or 2 cubed times 3. Those would be the prime factors of 24. Now let's determine the LCM of two numbers by using prime factorization, and let's begin with 12 and 16. So you do your division bracket and begin dividing. Both of them are even numbers, so begin dividing by 2 and see what you get, and then write in your prime factorization for 12. 12 is equal to 2 times whatever, and then 16 is equal to 2 times, and put the rest in, and then figure out your lowest common multiple using prime factorization. Here we go. 12 is 2 times 2 times 3, and 16 is 2 times 2 times 2 times 2. So the LCM would be Look at the 2's. Which one do you use? Not 2 times 2, that's too small. Use the larger number, 2 times 2 times 2 times 2 times 3. You have to use all the factors. Use it as many times as you have it. And the answer is 48. The lowest common multiple of 12 and 16 is 48. So it's 2 times 2 times 2 times 2 times 3. Let's do another one. Find the LCM of 45 and 54 using prime factorization. So let's factorize 45. That's an odd number, so begin by 3. Dividing by 3, and 54 is an even number, so begin dividing by 5. Now you see how complicated it gets, and it's pretty hard to do it by listing. Let's see if you can do it by prime factorization. So do the prime factors for 45 and 54 and then figure out the LCM. Do it quickly. And here we go. 45 is 3 times 3 times 5, 3 squared times 5, and 54 is 2 times 3 times 3 times 3 is equal to 2 times 3 to the power 3. LCM, since the prime factors are 2, 3, and 5, we have to use each of them. So let's look at the 2. For the 2, we need 2. For the 3, we need 3 times 3 times 3. And then for the 5, we just need the 5. So it's 2 times 3 to the power 3 times 5. The answer is 270 when you work it out. Okay, let's write the numbers you have to multiply to get the LCM. So we just need the expression where you multiply the numbers, not the answer itself. 36 and 90. So look at the prime factorization and see if you can write the expression you need to multiply to find the LCM. So look at the prime factors. There are 3 of them, 2, 3, and 5. What do you use for the 2? What do you use for the 3? What do you use for the 5? Okay, number 2, 40 and 60. Again, same thing. So we've done the prime factorization for you, and the prime factors would be 2, 3, and 5. Again, look at the 2. What are you going to use for the 2? Look at the 3. What are you using for the 3? Look at the 5. What are you using for the 5? That's all I need you to write for me. 2 times 2 whatever times 3 whatever times 5 whatever. And then that's it. Don't work it out. Just put that as the answer. Number 3. Look at the factors again for 63 and 90. So the prime factors would be 2, 3, 5, and 7. So you use all of them and use the greatest number. So look at the 2. What are you going to use for the 2? What are you going to use for the 3? What do you use for the 5? What will you use for the 7? Write it out without giving the answer. So do it quickly. This will show if you really understand what you're doing. And this is the hardest part of LCM. Number 4, 24. The prime factorization is done. 54, the prime factorization is done. What are the prime factors you're looking at? 2, 3, 2 and 3, only 2 and 3. So what would you use for the 2 to multiply by the 3? And what are you going to use for the 3? Put that in as the expression you would use to find the LCM using those prime factors. Number 5, you have 3 numbers, 90, 45, 54. The prime factors we're looking at 2, 3, and 5. What do you use for the 2? What do you use for the 3? What do you use for the 5? Remember, you want to use the greatest number of factors for each one to find the LCM. So put what are you using for the 2, multiplied by what are you using for the 3, multiplied by what you're using for the 5. That would be your answer. Answers: 36. The expression you needed was 2 times 2 times 3 times 3 times 5. Right. Because you use the greatest number 2's, use the greatest number 3's, and use the greatest number of 5's. So it's 2 2's, 3 3's, and 1 5. So this is the way for you to look at it in order to get the answer. Once you know what the prime factors are, figure out how many of them you're using and use the greatest number. That's it. Number 2, the prime factors were 2, 3, and 5. For 2, we have to use the greatest number 2 is 2 times 2 times 2. For 3, it's just 3. And for 5, it's just 1 5. So it's 2 times 2 times 2 times 3 times 5. That's what you're going to use to find the LCM. Got it? Just look at the prime factors and choose the largest number of factors that you have, the greatest number of factors that you have. Number 3, the prime factors are 2, 3, 5, and 7. So for the 2, there's only 1 2. For the 3, it's 3 times 3. That's the greatest number, so you use 3 times 3. For 5, is only 1 5. For 7, there's only 1 7. So the LCM would be 2 times 3 times 3 times 5 times 7. That's it. Just look at all of the prime factors. You use all of them and you use the greatest number for each of them that you have. Just remember that and you're straight. Okay, number 4, prime factors were 2 and 3. So look at the two and see what you're going to use. What's the greatest number 2s you have? 2 times 2 times 2, yes. And look at the 3, what's the greatest number 3s you have? 3 times 3 times 3, so that's it. So it's 2 times 2 times 2 times 3 times 3 times 3, or 2 cubed times 3 cubed. That would give you your answer for the LCM for 24 and 54. Getting it? Okay. And the last one, 90, 45, 54. The prime factors were 2, 3, and 5. What will you use for the 2? There's only one 2, so use that. For the 3, 3 times 2 times 3, greatest number 3, so you use that. And then for the 5, there's only one 5, so you use 1 5. So the expression you need is 2 times 3 times 3 times 3 times 5, or 2 times 3 cubed times 5. Same thing. And then you multiply and put your LCM once you know what the expression is. Let's find the LCM of 15, 24, and 32 using prime factorization. So let's find the prime factors of 15, prime factors of 24, prime factors of 32, and then find the LCM. I gave you a clue there. The prime factors are 2, 3, and 5. So for 2, what are you using? For 3, what are you using? For 5, what are you using? Remember, use the greatest number of factors that you have. So do the prime factorization quickly. Here we go. 15 is 3 times 5. 24 is 2 times 2 times 2 times 3. And 32 is 2 times 2 times 2 times 2 times 2. So we're looking at 2. For the 2, we need 2 5 times 2 to the power of 5. For 3, we need 3. And for 5, we need 5. There's only one. So the LCM is 2 times 2 times 2 times 2 times 2 times 3 times 5, which is 480 when you work it out. 480. At 16 and 24, put in the numbers that are missing. So put in the missing numbers on the factor trees, and then I want you to figure out the LCM of 16 and 24. So put in your numbers, fill in the factor tree. Yes, there you go. 16, fill it in, so you get 2 times 2 times 2, and 24, 2 times 3 times 2 times 2. So for the LCM, you use 2's, you need 4 2's, 2 to the power of 4, 2 times 2 times 2 times 2, and you only have 1 3, so the LCM would be 48. So use the same method where you look at the prime factors, and choose the greatest number that you have for that prime factor in order to work out the LCM. Thank you all for watching this video. Hope you enjoyed it and you learned something new, and we'll see you in the next one. That's a wrap.